As Dimitri said, my name is Sergey, and I just recently moved to London. That's my first time in London, but it's already for 4 months. So today I will talk about how to cook a MVI dish or model view intent. A little bit about myself. I'm an Android engineer who turned to be as such from backend and web. I'm really involved in the communities, and I was an organizer, co-organizer of Kotlin User Group in Russia, in St. Petersburg, the first one, Kotlin User Group, and Android Academy schools in a couple of our big cities. So back to the topic. I wanted to highlight a couple of problems of modern Android applications. Well, obviously, we have a lot of problems right now, but a couple that are the most interesting for my topic. The first one is big code bases. Whether we are a startup who just caught the wave of success and starts adding features like every week, or we are a big company already, we have quite huge code bases, or may end up with quite huge code bases. That makes it quite difficult to navigate there. The next one is lots of asynchronous communication in our applications. We have REST backends, we have WebSockets, push notifications, some events that are coming from our operating system, and all these events, they usually have some impact on our application. They probably change somehow our state. If we will combine the size and async problem, we will end up in a situation when something changes something in our application, and we just don't know what was wrong, how our state of application was crippled. And it's actually a pain in the ass to find out where and at what point of time in particular it went wrong. Common state is supposed to solve this. Why? Why is that? I will highlight some pros of this. If we will gather all the state in one place, it will be a single source of truth, not just a bunch of flags and primitives scattered across our application. It will be easy to check this state in any particular time because it won't be scattered. It will be in one place. If we have one place to change it and check it, we may observe clear sequence of these changes. And that makes it quite easy to find a problem when some state change crippled our application. As a side benefit, we have quite easy decoupled testing here when our state is in one place again. Common state is the cornerstone, is the heart of the approach to architect our applications, also known as Unidirectional Data Flow. What's that? Basically, we have our user interacting with our application. These interactions, they become the intent to change something. This intent goes to our module. Module changes the state of application, and this new state is just passed to the view to be rendered and shown to the screen again. And then this circle just repeats itself. That's basically the core part of model view intent, simple schema. My journey with model view intent started from this talk. Can you raise hands who saw this talk? Yay, quite a lot, but not all of us. So this talk is basically like a sequel of Jake's talk, and I will kind of base my stuff on that. So let's remember a bit of his content. We will have this simple application with a search bar, and we will search some stuff on a backend. We will input a query and get results. How we may construct this in a naive Rx-based way. Something like this. We will get flow of our clicks. On each click, we will disable the button, then perform the request, show progress, hide progress, show errors or data that came from server. What's bad here? Bad is that we read our state basically in 2 places here, and we change our state, our UI state, and even more in 5 places here. That's quite a lot. And probably we are doing some kind of redundant hops in between state and our logic, in between UI and our logic. So can we simplify this? Yes, we do. Let's use some abstractions abstractions are used to simplify things, right? We will get this abstraction of UI action that user is performing. We have just one search with the query that we entered. And we have an abstraction of our UI state, which shows either loading, data, or error state. And refactor our code. It will look like that now. So basically, we just map our clicks to our actions. That's just one place where we read our state. And we have this observable of all the information from the user interface. Then we perform our business logic. We just go to the server, map this to loading, content, or error states, and we have this observable of states right now. And after that, we just subscribe with render function that can render all this in one place to our UI. Quite easy. So basically, we have these two places where we interact with our UI, when we read and when we render this. Side benefit of this is that we can just move our business logic that's uncoupled from Android right now to some separate component and provide all the dependencies by dependency injection, and then just bind it in some UI part. So this component will be bound to action from the event from the user, and user interface will subscribe with the render function. We got this, we had this, we got something like this. A lot easier to reason about. So this part actually looks like a textbook implementation of model view intent. It's just three functions, render, state, action in our case, because view and intent obviously are occupied in Android. And that example is quite simple. I mean, very simple. But what if we will have some added complexity here? For example, two network requests that we need to combine, and their results we need to combine to show on the screen. Something like that. We will show search suggestions. We got one action. Now we will have two actions. Second one will be just loading suggestions based on this same query that's entered in the input. And UI state will change quite significantly. Before that, we had three separate states, but right now it will be kind of a complex state that will show what our UI is representing. We basically don't care about either our suggestions are loading or they ended up with errors. We just care about whether we have suggestions or not. And this loading, data, and error will represent our results from backend. Results of search, not suggestions. And you may ask that somehow we need to reason about the results of our network requests that still will be separated from each other. How we will do that? We will introduce this internal action abstraction, one more abstraction here, that basically will represent this network results. So it's the same loading, it's the same success, it's the same failure, and one more edit thing, success of loading suggestions. I will tell you a little bit later about why this is called internal actions, but just remember about this right now. So how will our bind function with business logic transform? We have now one stream of actions, but we have two different types of actions there, and we need to split this somehow in the business logic part. So we will use publish operator here to multicast this, then filter by type of the event, then produce some business logic separately, do some actions with search action and load suggestion action, and then merge the result into the observable of results. How these business logic parts will look like? Basically the copy-paste of the simple example. So the topmost part just reflects the search actions, and the bottommost part will show us the results of search suggestions. The only part that differs is that instead of UI state before, now we will use this internal action as our result for component operations. So then we just merge this, and we need to somehow represent this in terms of UI state. What will be rendered on the screen? For this, we will use scan operator. That's basically a fold or reduce in terms of functional operators. And here we will do something like that, big when operator. What are we doing here? Basically, if we will have loading action as an input, we will change just the loading flag, and we'll clean up the error and suggestions, not show them on the screen. If we will have our data successfully arrived, then we will show this data and clean up all other flags. Failure, clean up our loading, show error, and if we got suggestions, we just show suggestions, not changing anything, considering anything connected to search results. When we have some actions that are not important for our business logic, we will just skip them through. That's basically the skeleton of our business logic here. And here we can see quite coupled relationship between business logic and this state modification. So first we will do some business logic with going to the server, maybe loading some results, handling them, and then we will change the state, what is represented on the screen. What if we may want to decouple this part? For example, some state changes, some actions don't need to be passed through these binders through these logic parts, just like they should change the state, that's it. For that, we may refer to our colleagues for their experience. Unidirectional data flow is quite often used on website. And you may have heard about such words like Redux, that was introduced around maybe 2015. Cycle.js from Andrew Staltz, that was introduced in 2014. Or maybe Flux from Facebook also appeared in 2014. But all of them, they actually didn't bring something new concepts here. The one who did was Elm programming language. And key part here is that it's programming language. It means like not a framework, but this whole concept was baked into the main architectural pattern there to architect their web applications. Let's see how typical Elm component will look like. We will have our user interactions. That's mapped to actions. Actions are paired with the current state, and this all goes through the update function that performs some state changes. This will output new state. New state will go to render function, and it will be rendered on the screen and shown to the user. But that's not the only part that update function is doing. It also emits some side effects that we need to handle. These side effects will go to call function, and call function will do this side effect and represent the result as an added action that will be redirected to the head of the queue. So the whole component, is called Elm Component. You may think that this update, call, render stuff don't actually mean anything to you. But if you're familiar with Redux, you probably have heard such names as reducer, middleware, and store. And that's basically the synonyms of the stuff that was represented by Elm. And right now it's a little bit more clear what these functions are doing. Reducer is responsible for state changes, middleware for side effects, and store just gathers all this together. If we will look closely to our implementation of business logic, we may spot some similarities and understand that this part is, in particular, a reducer implementation. This part looks very similar to middleware stuff, and altogether it's a store. And now is the time to remember about our added abstraction, these internal actions. Why are they actions? Well, at this schema, you may have noticed this stuff. And that's basically a representation of side effect execution. It is basically an action because it goes to the beginning of the queue to be handled as other actions, but that came from user. So what about our parts? Reducer is basically a function. Here, for more, I would say, clear explanation, I represented this as an interface. For reducer implementation, we just move this stuff from when part under the scan inside the implementation of reduce function. That's it, just copy paste. Middleware is also a function that maps observables to observable of state and action to another observable of actions. Also just a function. We will take this bind functions that were introduced before and just copy paste them here again. If we really need to interact with current state, we may add this with latest from operator and integrate observable of current states as well here. And how our store will look like in this concept. So again, let's return to this schema. And what's in particular interesting here, it's our input and output to the component. We, as an Android developers, we know that when we return the screen, we should bind and unbind from our execution and other stuff because we may leak our UIs, our views. And here is basically the point where we should bind and unbind from the view. But if we will unbind from this subscription, we're using Rx here, all our current operation will be lost. And we don't want that. So we will actually have two circuits here. One internal, that's inside the box, and one external that will be binned to the UI, where red arrows are. How this will look like? We will just use this state and action buffer that will represent our UI mainly. We use here relays from jQuery, and basically you can use subjects. That's the same stuff. Just don't react for on error and on complete. And we will wire up this internal circuit first. So we will get our actions buffer. We combine this with state, go through reducer to change the state and get the new one, and subscribe our state buffer for the results. Obviously, you need to remember that some states can be exactly the same, so we need to filter them. The second part is the middleware, and here we are unbinding these two parts from each other. So middleware works separately from reducer. There is no ordering between that, as was before. So here we just merge results of our two middlewares, and this result goes to action buffer again. That will be handled with reducer with the topmost part. So that's wiring of the main circuit inside the box. And this will be getting the actions and producing the new states as soon as we fire our request, for example, fire our interaction. What with views? With views, we have this part. We just need to pass our actions from views and our render function that will render this on the UI and bin this. And bin this to our buffers, state buffer and action buffer. We may go even further and abstract this to parameters as an MVI view interface that will be implemented by our activity, fragment, whatever. So this will look something like that. When this feature will be completed and we will start a new one, we may end up in a situation of copy-pasting basically the same structure of a store and implementing this once again. But the only part what it will be different is this UI state, that's our initial state basically for the interaction, reducer, and number of middlewares that will perform side effects. Let's just abstract them as parameters. We'll provide them through DI, for example. Introduce some generalization through generics, and here we have our reusable store class that basically is capable to do all the functionality of our kind of small Redux implementation. And this implementation in particular will consist just of a few classes, like basically 3 interfaces in one class, not even deserves to be called a library. So you can just copy paste this in your own project. What is left is to discuss how we will bin this all together to the view. There are several things that you may do. First one is Jetpack view models. View models will leave across your orientation changes that may help you. You may set up custom DI scopes that will also leave through the activity destruction on rotations, or some other custom state management, why not? I will show you an example of using view models because it's just that simple. We will get our constructed store with correct dependencies from dependency injection. On time of creation of this view model, basically when we first open the screen, we will wire up the main circuit, the component itself, and we will dispose this only in on clear. So just when we really exit the screen, not rotate the activity. And in on pause and on resume, we will just bind and unbind our view. That's it. Very simple. Again, basically like 10 lines of code. That was quite a lot of code and some other code and code again. So let's kind of try to visualize this a little bit more. That's our feature, our search engine with suggestions. What will happen with interaction when user will interact with our component? First one, we'll get search action from the user. This action will be mapped to our initial state, empty one. We'll get through reducer. Reducer says nothing to do here, just emit empty. And that will go to middleware then. Middleware will fire network request, emit loading action. That will go to the beginning, will be mapped again to our state. This new pair will go through the reducer, and reducer says, okay, let's show the loading indicator then. This will be rendered, indicator will be shown, and at some time, yeah, our state will change. And at some time, we will get the result of our network requests. This will trigger middleware. It will emit search success action that will be mapped again. Will go through reducer. Reducer will hide the loading and show new data. It will be again rendered to the screen. Quite clear and straightforward path of our data through the components of this kind of unidirectional data flow implementation. That may seem very convenient and easy, but obviously all the time we will have some drawbacks here and there. And here we have some as well. You may end up asking, what if our user will be a monkey runner, for example, that will be tapping our UI buttons as crazy, or maybe someone will just push a lot of events in our stream. It will end up rendering a lot of UI states. Yeah, so we will get lots of state updates that we will need to render, and it may be quite difficult for our rendering engine. Something like that, when we cannot handle the flow, the incoming flow. For that, you will have something to deal with this, like separate libraries for that. No need to write anything by yourself. One of them is Litho from Facebook. It's a declarative UI framework for constructing your UIs. The nice part here is that it performs recycling for all the stuff. Not only your concrete items in recycler view, but basically you can recycle your separate text views, just like widgets, all that stuff. And it has asynchronous capability of asynchronous layout. So if your layout is quite complex, you may offload part of the layout process to the background. That means you will get some work from UI thread, it won't block it. The second one, quite interesting and different approach is Domic from Lyft. It's not production tested, I would say, but probably production ready. The pros here is that it uses the same Android widgets, not the custom stuff as Litho, just wrapping them. It has different of changes, so you won't end up rendering same text twice, for example, if it will come with the UI state from our Redux implementation. And it's basically reactive from the ground up. It means that you can wrap up your Rx bending streams, for example. That's rendering. And next part is next question is clean architecture. So for example, if I really persuade you that this is kind of a nice try and you should try this in your project, probably you will ask me like, we have this quite big application, we use clean architecture here, and why should we rewrite all this stuff? Like, it's really worth only a pet project, or maybe not. So here is our state of the architecture. We're communicating with API here. Okay, if you are not as lazy as me, probably you will get a repository implementation that will encapsulate API and SQLite. And then you will see that middleware basically is something that showcases the use case of your interaction with the server. So word use case kind of suggests that this may look like an interactor probably. And that really is. That really is basically an implementation of a use case. You just need to change your interface to use observables here. And what is left is basically a presentation layer, store and reducer in your implementation of MVI view. So actually, just like presentation layer, the only part that needs to be changed, and you can really experiment this with this feature by feature. And data layer and domain layer basically stays the same. To wrap up, MVI is about presentation logic. Again, as all MVX stuff. It's not about re-architecturing the whole your application. Your repository and business logic may be structured the way you like it more. It is really based heavily on reactive flow. So we are here using Rx. With sealed data classes, actions, states, immutability, we provide all the, like Kotlin, provide all the niceties to implement all this stuff quite effectively and safely, because we need immutability here to be safe, to offload this to background threads and all this stuff. Also, Kotlin multi-platform is quite a hype topic right now. So we're using Kotlin here. What about possible implementations of this kind of presentation architecture using multi-platform approach? It's okay, if not Rx. Rx Java is JVM only, so we cannot use this on other platforms. But what if we would have something like Rx Kotlin, but real Rx Kotlin, not that fancy wrappers that we have in the repository? Actually, there are approaches to implement this. One of them is Reactive, library from Badu. It is quite intensely developed right now. I think it's not production ready yet, but we have folks from Badu here, and you may ask them, I guess. It's quite interesting to observe the development process, nevertheless. And the second part is also quite new, is coroutines flow that was presented not so long ago by Roman Elizarov from Coroutines team. That's basically an implementation, coroutine implementation for cold observables. That's really helpful for our case. And that nice thing, time travel debugger that I was not showing you, but I will tell you about. When you have this quite clear sequence of changes, it is really easy to just report your current state and the action that caused this state when your application crashes. And just try to apply this state to your sandbox application and see how this will be reflected on UI side. What will be crippled there? What will crash? It will really help you to reproduce bugs on client side. Our implementation was quite simple. You saw that for classes, but obviously someone already tried that at home as well. And there are several approaches, several kind of different approaches for that, and quite big examples of that. The first one is Rx Redux from Freeletics and Hannes Dorfman. I would say the not so nice part is that it's not a pure MVI implementation. It's basically like an Rx approach to apply to Mosby of Hannes Dorfman library. So we didn't like that when we were trying this. The next one is Mobius from Spotify. Mobius is nice in that side that it's decoupled from Android totally, and it doesn't use RxJava as well. So that's very custom implementation. It has plugins for Android UIs, for some other stuff, and you may try this, but it's really complicated and you may not like it as well. Next one is Mavericks from Airbnb. You know that Airbnb gave up on React Native, and they basically just implemented React part on their own. That is really nice, and the library itself feels very good, but on the other side, it is very coupled to Android specifics, Android UI, lifecycle, all that stuff, and they use Airbnb epoxy library for rendering UI. That also may not fit to your needs. My personal favorite, again, Badoo, MVI core. What I like here is that's basically a lot more complex implementation of what I was talking about. And these guys obviously were inspired by Elm architecture as well, because this looks quite similar. I suggest you to follow to their repository and read their README. Also, it won't be honest to not mention a couple of more. Grox library from Groupon and Suas library from Zendesk, they are not so popular. The time I checked, there were not so much stars in GitHub. But nice thing about Zendesk implementation is that they have really working time travel debugger, and you can try that and see how helpful it may be, how really helpful. Just as a first step, follow their README and check out the documentation. As I said already, my personal favorite is MVI core. So if you will open README, you will see such names as wish, effect, actor, and feature, and probably that won't tell you anything. But I will give you quite an easy life hack here. Wish is an action from this talk. Effect is an internal action, actor is a middleware, and feature is a store. So now you have this very simple Redux to MVI core dictionary. Use it. Yeah, just a bunch of useful links here and there. No need to photo this. I hope slides will be available actually. Jake's talk of Ryan about reactive workflows, about their approach to combining reactive features all together. Quite nice to understand this big picture of big application. Information about Litho, information about Domic, observation about Kotlin coroutines flow library, reactive repository for Badoo implementation, and reagent repository from Jake, kind of his pet project to implement observables based on channels and coroutines. Also as a good study material. Project is abandoned right now. And that's it, basically. Thank you very much for your attention. Questions?